common number systems. We know there are different types of number system: decimal number system, binary number system, octal number system, and hexadecimal number system. So how we can differentiate all of these? Because of the base. Decimal having the base 10 symbols from 0 to 9. Binary has base 2, counts 0 and 1. Octal has base 10, is count from 0 to 7. Hexadecimal number having the base 16, counts from 00 to 15, is nothing but the F. And what is the basic difference between all of these? These are the decimal number system mostly used by the humans but not used by the computers. Then binary number system used by the human? No, is not used by the human, is used by the only computers. And remaining are octal number system used by the computer? No. Used by the human? No. Hexadecimal number system is also not used by the human as well as the computers. Then counting. Whenever we think about to differentiate all of these four, so decimal is count from 0, 1, 2, 3, 4, 5, 6, 7. So equivalent number for binary is given. For 1 it is 1, for 2 is a 1 0, for 1 1 is a 1 1, for 4 is a 1 0 0, for 5 is a 1 0 1, 6 is 1 1 0, 7 is 1 1 1. So actually this is we can find out by using the weight method. What is that? That I told you later. Same octal number, but we know about the octal is count from only 0 to 7. So your octal numbers is same as your decimal numbers. Same hex number is from 0 to 7. Okay, this is very interesting. When it's a decimal number 8, octal number is a 10. Because why? Because octal only counts from 0 to 7. Whenever we are going to think about the decimal number 8, so octal representation is 10. And for hex it is the same as 8. For 9, binary is number 1001 and octal is 11 and hex number is 9. For a 10, binary number is 1010, octal is 12 and hex equivalent of 10 is a 8. For 11, same thing, is a 13 octal number and B is a hex number. So as so on. For a 15, binary number is 1111, octal is 17 and hex number is F. Then right now we have to discuss about the different types of number system: decimal number system, binary number system, octal number system and hex number system. Just start with the simple decimal number system. What is that? It's having the base 10 and it's count the digit from 1 to 9. For that we have a simple representation. For any number system we have a same rule. From left to right is your fractional part. From right to left from the base is your integer part. But this is the decimal number system, so we can find out any number is a integer from 10 raised to 0, 10 raised to 1, 10 raised to 2. And for a fractional part, your values are 10 raised to minus 1, 10 raised to minus 2 and 10 raised to minus 3. So weights for the whole numbers are the positive power, that is increases from left to right. For integer part, always begin with the 10 raised to 0 is nothing but a 1. For a fractional part, the weights are the negative powers of 10, that is decrease from left to right beginning from 10 raised to minus 1. Take a simple example. I have just read the problem. Express the decimal number 87 as the sum of the value for the each bit. 87. So no fractional part is given, only integer part is given. So what we can do here? 87 we can write in the sum of weight. So 7, it is from right to left, so 7 into 10 raised to 0 plus 8 into 10 raised to 1. So it is equivalent to 87. Then take another example. Express the decimal number 725.45 as a sum of the values of the each digit. So what we can do? we can keep integer part and fractional part separately. So for integer part, it starts from 5 into 10 raised to 0 plus 2 into 10 raised to 1 plus 7 into 10 raised to 2. For a fractional part, we can write down the negative values. So it is 4 into 10 raised to minus 1 plus 5 into 10 raised to minus 2. So total will be 700 plus 20 plus 5 plus 0.4 and plus 0.5. It's a 7, 2, 5, 45. Then next is what is a binary number system. Binary is a very simple, whatever we have a digits that is having the base 2 and its bits are 1s and 0. And as we write a number representation for a decimal number system, same, but here only we have to change the base, that is again keep 2 as a separate part, integer part and fractional part. Dot is you have given as a base, so it's a 2 raised to 0, 2 raised to 1, 2 raised to 2 onwards. This is your integer part. From 2 raised to minus 1, minus 2, minus 3 is your fractional part. Here again one thing is we have given LSB and MSB. What is that? Leftmost bit in a binary number with the higher weight is called the most significant bit. In a short we say is the MSB. And rightmost bit in a number with the lowest weight it called as a LSB or a least significant bit. In a binary format we have a few things. Bit always having the size 1, nibble having the size 4, byte having the size 8, word having the size 16 and double word having the size 32. Octal numbers. What is that? Simple thing. It's count from 0 to 7 and its base is 8. So octal number system provides the conventional way to express the binary numbers and codes. So its counting is similar to the decimal, but here 8 and 9 is not present. Means whatever you are counting in an octal is always from 0 to 7, then 10 to 17, 20 to 27, like this. Representation is same. Again we can keep integer and fractional part as separately. Most significant bit LSB, that is also same. Here only we can change the base. For integer is started from 8 raised to 0, 8 raised to 1, 8 raised to 2. For fractional it was from 8 raised to minus 1, minus 2 and minus 3. So last least significant bit is your LSB, most significant bit use your MSB.